Whiteboard Sabrina, can you please help me solve this problem? Okay, so our first step for curve sketching is finding the derivative. And as we know, using the power rule, the derivative of this equation would be negative 4x to the third plus 4. And now we're going to find the critical points. The critical points are the zeros of a function, kind of like in algebra. So I'm going to solve for x in this equation. I set it equal to 0. I'm going to subtract 4, and I'm going to get negative 4x to the third equals negative 4. Solve for x, you get x equals 1. So I have a negative 4 cubed root. So since x is only equal to one number, I know that the function has only one critical point. And to find whether the function is increasing or decreasing during certain intervals, I'm going to put my critical point, or if you have two critical points or three, on the graph, on a graph, just so you can see. And this number line is decreasing to negative infinity and increasing to infinity. Sorry, my infinity sounds so bad. But I'm going to put my critical point on the graph, and it was x equals 1. So now I want to see whether the function is increasing or decreasing during both of these intervals. So this is one interval and this is one interval. So to see whether the function is increasing or decreasing in this interval, I'm going to pick a point that lies between these two numbers. So I'm going to pick negative 1 because it's between 1 and negative infinity. So I'm going to plug that into my derivative. So I'm going to get negative 4 of negative 1 cubed plus 4 equals y. So that leaves me with y prime equals 8. And since I know 8 is greater than 0, what that tells me is that in this interval, the function is increasing. So I'm just going to put a plus sign to signify positive or increasing. So now to look for this interval, I'm going to pick a point here, and I'm just going to pick 2 because that falls between this point. So I'm going to plug that into my derivative again. And that will give me negative 28, and I know that negative 28 is less than 0, which means that the function is decreasing here in this interval. So for my answer, I would write increasing in the interval, negative infinity to 1, and decreasing from 1 to infinity.
Wait, but why do I even need to know this?
Well, that's a great question, Abby. Do you hope to be an engineer? No? Well, for instance, imagine that you're representing a stress or strain relationship in mechanics. It could help you understand a material's breaking point under stress, which could be the difference between whether a construction building falls down or stands up. In electrical engineering, curves can depict the voltage to current relationship in a circuit, and it can assist in troubleshooting and improving circuit performance. So to you, it might not seem like the most important thing, but actually, curve sketching is holding up our entire world right now. Now, Whiteboard Sabrina, can you get into solving for the relative maximum and minimum? Okay, to find the relative minimum and maximum, we can now look at this graph. And since I know that this is starting off increasing and then going to decreasing, this will actually be our relative maximum at x equals 1. The rule is when the function goes from decreasing to increasing, the function will have a local minimum. When the function, like this one, is going from increasing to decreasing, the function will have a local maximum. We know that when x equals 1, that's our local maximum. That's because that's when the change from increasing to decreasing occurs. If you have a function that's going increasing and then decreasing, we know the point where it's changing will be the relative maximum. The reason we know there's no relative minimum in this function is because the function never shifts from decreasing to increasing, which means that the function never has a lowest point. This function is continuously going downwards to negative infinity. So therefore, we don't know what the relative minimum would be because there is no minimum. And since relative minimum and maximum must occur at a specific point with a finite interval, negative infinity cannot be a minimum. And therefore, that's why there is only a relative maximum for this function. And this applies to all other functions as well. Okay, whiteboard Sabrina, I'll let you continue from here. So now to find the point of the relative maximum, the y value, I'm going to plug 1 into our original equation. So I'll get y equals negative 1 to the fourth plus 4 times 1 minus 8, which gets you negative 5. So I know that the relative maximum is